Okay, so we're getting into pictorial, today. So pictorial is really easy, We're gonna draw 3D out of 2D. So it's just a virtual 3D drawing, and we're gonna do it on the 2D plane, which is your 2D drawing, okay, that looks like your 3D object. So why do we draw the pictorial? It's because we want to visualize our design and design idea. So this is what we're gonna do, and also of course you can be able to read the print, easily, because your pictorial is gonna help you, to be able to understand these projections or the print. Okay. And Pictorials also, they're very effective in drawing your assemblies. So when you put all the pictorials objects together, you can be able to see how we're gonna assemble that. Part or model. Okay. We have three projection methods. Isometric and then oblique and then perspective. We don't really use a perspective. We use this isometric and oblique, quite commonly, and we will get into each one of them. Of course, in isometric, your ISO is very well known. 3D pictorial, and in oblique we use a cabinet. Oblique. So this is what isometric pictorial looks like, and this is what oblique pictorial looks like. So the very first group is your isometric projections, and again we have sub types, and these are three types, of your isometric projection. The very first one is your isometric, the second is your di, and then tri. So when you study, you have to train your eyes to be able to recognize the differences. So when you take a look at it, we have drawn to scale, same scale, and then here we're drawing with a different scale on each axis. That's all right, So the major difference is you can be able to see the scales are different and the angles are all different. Here we have the exact 30-degree on each side of your axis, and here your three axes. So your angle is with the horizontal. See the little line right there? That means that we're drawing the angle with the horizontal, measuring from the horizontal line. So here both angles, see, they are theta. So theta is just a variable, so just showing you that the angles can vary between 0 to 45 degree. Okay, definitely you can take 30, because if you did take 30 and theta is equal to theta, so 30 and 30, then you will have like isometric instead of your diametric. Okay, so for tri, look at that, we have two different variables here. Your theta and then your phi. Their variable definitely not 0. You have an angle with the horizontal. So when you add them up, you would have gotten like less than or equal to 90 degree. Okay. All right. So these are the differences for three types of your isometric projection. ISO 30-30 di, the same angle. It can be between 0 to 45. And then you try different angles. When you add them up, it is less than or equal to 90 degree, but they're definitely not 0. Okay, so that's what you have to get. Of course, let's take a look at with the cartoon. There's isometric, and you're gonna put a little horizontal line right there. You have 30-30 diametric. Okay, this one drawn to scale. This one is about the same scale on the sides. And of course, you're showing all of this. Look at this axis. And of course, this trimetric is going to be different scale on each axis, and then you have two different angles. When you add them up, they're less than or equal to 90 degree, but they're not definitely 0. Okay. All right, then we'll get into three types of your oblique projection. We use oblique projection in your cabinet. So it is the second one. We have true size, but different scale, full, half, and then scaled. It can be anything except full or half. And your angle, you have only one angle, and that can be between 0 to 90. The other angle is at 0. See, it's on the horizontal. Okay, so that's your oblique projection. And then the perspective, we don't really use it, but point meaning like perspective meaning adjust your side. So go with the one side, it's a 1 point. 2 sides is going to be your 2-point perspective, and 3 sides is going to be your 3-point perspective. Okay. If you know the name of that, that's okay, because we're not going into drawing for this perspective projections. All right, visualization. Yeah, Pictorial helps you visualize your 3D part. Yeah, what will your 3D part look like from your 2D projections? And sometimes you will be given 3D part, and you can be able to, yes, get the 2D projections out of that. Yeah, so it helps each other. Yeah, you can visualize your part. Also, you can be able to translate, yeah, between 3D and 2D, vice versa. Okay, so let's do an exercise. So you have your top front and a right side. So we have to choose, yeah, the correct one. So we're going to start with the edges. Look at that, 1, 2, 3, 4, and then I have 3 surfaces. Yeah, so 2 surfaces here, so that's out right away. I have 1, 2, 3 surfaces, 3 surfaces. So when you take a look at your front, is look at this. There is a, yeah, your features going in, not extruding out of it. So this is, look at that extrusion that is going in. So therefore this is your right Pictorial. So when you take a look at it, see edge, edge, cut, and then this one is non-cut edge. So here you can be able to see your top, front, and right side. Yeah, so we have a cut right there, so therefore that's so completely out right away. Okay, so between that, see, look at that, you have a circle. This one no circle. Yeah, there's a circle, so therefore that the second one is the correct Pictorial. Yeah, so train yourself to be able to spot your Pictorial and relate your 2D and 3D. Okay, let's learn how to draw Pictorial. We're gonna do isometric first, yeah, because it's commonly used in your isometric projections. So you'll be given a 2D projection, your top and your front view. We're given all the dimensions, yeah, the height, the width, and then the depth. Yeah, this is your width and then your depth, and this is your width and that is your height, because that's your front and then your yes, your top. Yeah, and we have to draw this. Okay, let's take a look at how we're gonna start. We're gonna start with the isometric 30 30, and you have 3 axes with the horizontal, yeah, measurement, and then we're gonna box it. Yeah, so draw straight up, and we're gonna stop along the your depth and then your height and then your width. Okay, dimension, so you will have to consult, yeah, with this dimension, yeah, according to that. So that's what we've been doing, 2.5, 1.5, and then 1.50. Yeah, you can go back here and you can be able to see it, or yes, one more, and here I will copy, yeah, copy this off for you so you can be able to see it. Yeah, so look at that, so 1.5, yeah, it's right there, 1.5, yes, and then this is 2.5, which is here. Yeah, did you see that? So 2.5 is going to be right there. Yep, and then look at this, 1.5 is your depth, and then 1.5 is your height. Yeah, okay, and then you're gonna draw all the parallel lines. Yeah, the parallel to your axis, of course, and don't draw anything that isn't, yeah, there. So let's paste a little diagram here for you to see it. Okay, so see, like we're drawing according to that. So your top, yeah, you got to stop right here. I said it so. Okay, and then there's another one, but we don't have it here for a while. Yeah? Your bottom, yeah, your bottom is going to be this, because that's your front view. You have to stop right there. Yeah, I said it so. Yeah, look at that. Okay, so 2.5, yes, and of course you're gonna stop where, and that is given to you. Yeah, this is about yes, 5, yeah, because it said it, so here 0.5, yeah, and here too, see that, yes. So when you look down from the top, you know that this is about a 0.5, yeah, so that we get the edge. So you draw that, yeah, draw this, you draw that, and of course you do the same thing for your right side also. Right side, we can just look at it right here, yeah, because you need the right side view anyway. So we have a first cut is at 1, yeah, so right there. So now we completed drawing, and then we will draw by connecting the rest of them. So we get our inclined surface right there, and then our cut edge right there to the corner. And then we will erase all of the construction lines, yeah? So you get your neat little 3D drawing, your isometric, yeah? Pictorial. Okay. Pretty, it's not bad, yeah, not too bad. Okay, next one, we're gonna draw. So we're given this, so I'm just gonna copy it, so we have to take it with us for the dimension anyway. So pay attention to your height, okay, sorry, your height, and then your width, and then your depth, right? So that's your top, and then this is your front. We're gonna start exact same thing, 30, 30 for isometric, your 3 axis, yeah, with the horizontal, and we box it. We're gonna keep our dimension 50, 100, and 40 according to your projections, okay? Yep, yeah, here, 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 yes, okay. And then we are going to draw the lines of the object that are parallel to your axis, yeah, again according to your projections given, but this is given to you, so you know where to cut, yes. So here you go to the top, and then you start looking at it. Oh, I have to cut here, so how much is it? You start to calculate. The whole thing is 100, from here to here is 30, okay? So that's go all the way through to the bottom, so you can be able to do that. On the side is 60, yeah, on each side is going to be 15, okay? And the height is going to be 20, so from here all the way up is going to be 20, yes? So that is 30 because you calculate, yeah? From here all the way to here is 50, so that's 50. From here to here is 20 because it said it, so yeah? 50, 70, so this is 20. Therefore, the rest of them is you minus, yeah? From 100, so you ended up with 30, okay? Do your mathematics, yeah? I'm quite used to it, so I can go really fast, yeah? So anyway, so then we're gonna connect the rest of our line, yeah? So here, here, yeah? And that's your incline, yes? The surface right there, yeah? And then we will erase, yeah, our drawing lines, your construction lines. So now you have your, yes, 3D isometric projection, yeah. Okay, circular feature, how are we going to deal with that? So here we're given bang, 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 yeah, 3 views. We're given dimensions, the circle is 20, yeah, that means the radius is 10. When you pay attention to the gridding, look at that, so each grid is 10, yeah. So therefore altogether 4 grid is going to give you 40. 2 grid is 20. So 2, you know the diameter is 20 anyway, yeah? So you're dealing with a square, yeah, 40 on each side. And let's draw, yeah? It can be this, or it can also be something else because you can't, yeah, be able to see the height of that circle, yeah? This is right front, and then this is top, so you don't know if there's a height or not, yeah? So it could be the flat surface, or it could be a cylinder protruding up, yeah? So let's draw one of this or both of that, yes, from these projections. So let's start, okay? Isometric, yeah, 3 axis, box it. We're gonna draw squares into it. It's gonna be 20, yeah, one side, because it's 30, so your circle diameter is 20, so we will start drawing our squares. Every time you wanna get the center of your circle, that's what we do, yeah, diagonal lines go into it. And then you are gonna draw your circle inside of it. Erase your construction lines, and you're gonna get this, okay? Now, it could also be that, so we have to draw our cylinder up like that, yeah? So cylindrical features, how we're gonna do the same thing. Get another square, yeah? Give it a height, but it doesn't say what is the height of the cylinder, so you can give any height, okay? Connect your construction squares, and then put another circle, and then, yes, draw that, okay? So you get this, okay? So that's, of course, erase all of your construction green lines. So this is how we draw another possible 3D, which is your pictorial from your given projections, okay? All right, the next one we'll get into, yes, oblique axis, okay? So here your dimensions are given, your top view and then the front view. Yeah, from here to here is 100. From here to here, it said the radius of this big giant circle is 30. So altogether 130 is your length. Okay, and your width, of course, yeah, is from here to here, so that's a 60. Okay, and then your height, of course, is a 50. Okay, so we get all of our dimension. From here to here is only 20. Yeah. So we're going to start with the oblique axis. So we're going to use a cabinet, yeah, 45-degree. You have your 3 axes right there, yeah. Cabinet is, let's review. So you can either draw this or this, okay, either full scale or half scale. So if you just draw like a half scale, that you can be able to, so scale it down to 30. If you do a full scale, then you can be able to do the Cavalier, yeah. So let's just go with a full scale for Cavalier, yeah, and a half scale is going to be cabinet. So it's up to you, yeah. So this is your review for your oblique axis, yeah. So you know that in oblique axis, yeah, in your oblique projections, pictorial, yeah, and you know that the angle is only one angle, yeah. So only one axis is at an angle from your horizontal, the other one is 0, yeah. Of course, the most used angle is a 45 degree. So in our example, previous example, so you can see this, 45 degree, and this side is completely 0, yeah. And when we deal with our oblique axis, okay. So make sure you understand that. Okay, and then I told you, yeah, you can go either cabinet, yes, half, or cavalier, full scale. So this side, yeah, it can be half scale. So that means like when we go back to our problem, this can be 30 or 60, okay? I think your example in your textbook is showing with 30, yeah? I'm just gonna show you here, like you can make it to 60 as well. Yeah, that's up to you. And of course, you will keep the rest of them true size, yeah? So that's what it's saying, yeah? Keep this on true size. Your vertical and the horizontal, yeah, drawn at full, but your depth can be, yes, full or half, yeah? So for cavalier and cabinet, people usually use a half scale, which is your cabinet, yeah? So you can practice with the half scale. But then a lot of the students like the full scale. I don't know why, because it's easier for them to recognize the dimension. They want to keep the same dimension as in the projection. So they have an issue when they have to cut it half. Yeah, especially on your right side view, of course. So that's up to you. Yeah, I like Cavalier more than cabinet. I don't know why. I always go full scale. So let's try oblique. Okay. Pictorial step by step, and we're going to try cabinet half scale, yeah. So here our scales are given to us, and so you have your little pictorial that we have to draw from here step by step, yeah. And our dimension, of course, 2.50, yeah. So that's your top view, yeah. You are dealing with your diameter 0.050, so altogether this is only 1, yeah. This is, look at that, how tiny, yeah, that is. Your diameter is only 0.25, yeah, and you have 2 of them, it said so right there, yeah. And of course, and then your height here, yeah, 51, and altogether 1.25, yes. And then on this side, of course, your right side view is showing you your depth and then your height, okay. So let's take a look at this. So we're going to start with our axis, oblique axis, 0 and 45 on the other side, yeah. And we're going to do our full scale, and then you're going to do our half scale, yeah. And then we're going to draw the full scale for the height. So the depth, if you go back into here, you can see the depth, see? So we are talking about this, and we will do only half, yeah, not one for the depth, yeah. So let's go back, and this is what we're talking about. Of course, we are going to keep, yes, the length and the height, exact same thing, which is 3 and 1.25, yeah, 3 and 1.25 there. If I'm going a little bit fast, yeah, here 3, yeah, you spot it right, the height, yeah, 1.25. And then here the depth 1 will go half, so as 50. So since you go half, your circle gotta go half, yeah, half of 0.50 is 0.25. Okay, we box it. Of course, we do the same thing, axis, angle, and then box it. And we start putting in our lines, visible lines, according to our projections. Yeah, I don't have to go over that again. And then we are going to put our little unit circle. Yeah, size it down. So right now my circle is 0.25. Yeah, and this is, we're going to keep the same scale for the length and then the height. Yeah, and because that's a see true shape right there. And yes, erase all of your construction lines, drawing lines. Yeah, so now you have your pictorial drawn and have a scale. Okay. All right, the next one, 2D projections given to you. We're gonna do our oblique, yeah, practice. And here, your scale 100, the depth is 50. All right, and then your height is going to be 60 right there. Yeah, we start doing the same thing, box it. Your depth, we're gonna size it down half. We're gonna keep the true, yeah, size on this side, your vertical, and then your horizontal, the same. Draw your parallel, non-parallel lines. Okay, I'm going this way, yeah, parallel lines and then non-parallel lines, and then erase your construction lines. Okay, all right. Let's do the isometric for the next one. Yeah, our projections, dimensions are given to us, your top, your front, and then your right side. We start with 30 degree with the horizontal axis. Yeah, we are going to keep, yes, the dimension for 1.75. Yeah, see the height right there, see the length right there, because it started so here, started so there. Okay, and then your depth, yeah, of course your depth is 2.25 right there. Okay, it's just right here. And then of course do your parallel lines, yeah, non-parallel lines, yeah. This is just showing you the lines, existing lines as a guide, yeah, because you have a 1, 2, yeah, 3 inclined, yeah, surfaces on this side, so you have to go one by one. That's what it's saying, yeah. And then connect it and get rid of, erase the construction lines, yeah. Give it about about 10 minutes to study this. Yeah, I'm just going really fast because this is just showing you the lecture repeated. Yeah, many different examples. Another one, okay, doing the same thing, but this time we're going to use the oblique, same projection, 45 degree, and we're going to go half scale. Yeah, so we pay attention to our depth. Yes, so your depth is going to be right here. Okay, so half of that is going to be 1.125. Yeah? Look at this, 1.125. Keep this full scale, and your depth is going to be half. Yeah, so your cabinet, that's what we're doing. Do the same thing. Parallel lines, non-parallel, inclined, yeah, lines. We're gonna do, because you have a 1, 2, 3 staircase going on right there, yeah, so we go one by one. Erase your construction lines. Yeah, that's it. All right, that's it for this week, yeah, lecture. So make sure you study pictorial, yeah, all the way from the very beginning. Yeah, I'm gonna stop right here.